Good morning. Today I'm going to review the assessment we took on adding and subtracting integers. Now, you had 4 questions on this assessment. The first one says, use the rules for subtracting integers to rewrite the expression as an addition expression. So we have a subtraction expression. Basically, what I'm asking you to do is use the additive inverse, but I didn't use those exact words. Additive inverse means to turn a subtraction equation or expression into an addition one. So the rule for additive inverse is your first term stays the same. Subtraction turns to addition because that's the whole point of it, and our last number becomes the opposite. Right here, this is a positive 18. So it becomes a negative 18, which I'll put in parentheses. I put it in parentheses because I want to separate the negative sign from the addition sign. I don't want you to think this is a subtraction sign. Now, it does not say anywhere to solve, so I just move on to the next problem. Number 2 says, use the commutative property to rewrite the following expression. The commutative property means that when you have an all addition expression or equation, that you can move the terms around however you'd like. In this case, we had learned to move all the negatives together and all the positives together. Well, I have 3 negatives here and only 1 positive, excuse me. So there's only really 2 real ways I can write this. I can write all these numbers again with 17 in the front, and then all my negatives in whatever order I want going on. Or my other choice would have been to have all my negatives first, plus negative 16, and then had the positive or the plus 17 at the very end. So 17 should have basically just been moved either to the end or beginning of this expression, and that's it, because it does not ask us to solve. Question number 3 here says use the additive inverse. So I'm directly telling you now what to do to rewrite this expression. The additive inverse turns subtraction into addition. The only place I have subtraction is right here. So I'll follow the rules for additive inverse, which says the first term stays the same, the subtraction turns to addition, and my last term becomes the opposite. This is a positive 18, so it becomes a negative 18. And then I just attach whatever was with it. So my final answer is negative 21 plus negative 17 plus negative 18, because the additive inverse turns subtraction expressions or equations into addition. I'm not asked to solve, so I just move on. Finally, my last problem here is solve the following equation, show all work. So I'll go ahead and use the additive inverse right here where I see subtraction. I find that's a lot easier to do my work when I use the additive inverse. Subtraction turns to addition. This is a positive 33 because it's not in parentheses with a negative sign. So now I will make it a negative 33, which will be in parentheses with a negative sign. And just for looks, I'll put the first number, since it's a negative, also in parentheses, plus 25. Now, I don't have to apply the commutative property here because my negatives are already together. So I'll go ahead and just combine them. When I'm adding negatives, I just get a bigger negative. So negative 47 plus negative 33 becomes negative 80. Then I just drop down what I had, the plus 25. Now, if I think about this as money, I owe $80, but then I get $25 to pay my bill. Remember, when we're adding integers with different signs, you basically just subtract. So 80 minus 25 is 55. And then you take the sign of the bigger number. I have more negatives, so my answer is negative, leaving me with negative 55. That's the solution to all 4 of these questions. If you need to take the redo, please see Mr. Morales. It will be due by the end of the week.